Question 3 will require us to use the law of conservation of momentum. So the law of conservation of momentum tells me that in any closed or isolated system, the total momentum of the system remains constant. So remember, momentum given by P equals mass times velocity with the units of kilograms meters per second. Mathematically, I write the total momentum as the sum of P, saying add up the momentum of all my objects. And the law of conservation of momentum tells me that when I do this, I get the same value before and after the collision. So here are the two cars A and car B. The initial velocity of A, written U subscript A, is 8 meters per second. Mass is 1,200 kilos. So that's the situation of the problem before the crash. Afterwards, the cars crash and combine into one mass, and I've added their two individual masses to get 2,600 kilos, and we don't know the final velocity. Really important when we're dealing with vectors, and momentum is a vector, and it's got the same direction as velocity when we do the calculation. We need to indicate a positive direction for our calculations. So here, before I start doing any calculations, I'll let right be positive. Writing out a simple statement, the law of conservation of momentum implies that the total momentum before the collision equals the total momentum after. So the total momentum before the collision is equal to the momentum of car A plus the momentum of car B. And the law of conservation of momentum is telling us that is equal to the total momentum of the combined cars after the collision. Substituting in here, important to note that according to our positive direction, car A's velocity is positive 8 meters per second, whereas car B's velocity is negative 6.0 meters per second. Completing the working, we find that the velocity of the combined masses is 0.46 meters per second.